today we are going to be working on the first lesson of Chapter 4. Chapter 4 is about using proportional relationships in geometrical shapes and ideas. Chapter 4, Lesson 1 is about scale drawings and scale models. Scale drawings or scale models are used to represent objects that are too large or too small to be drawn to actual size. The scale gives a ratio that compares the measurements of the drawing to the measurement of the real object. Where do you see examples of scale drawings or scale models in the real world? Oftentimes, you will be asked to find a missing dimension or measurement when comparing the model to the actual. To solve for the unknown measurement, you are going to continue to set up the proportional one tables that we have been using with the information given in the problems. The original in these situations will also be known as the scale, which is the ratio, or they sometimes call it the key if we're looking at a map. You will then solve the proportion by cross-multiplying and dividing by the coefficients, showing all steps to prove your answers. We want to make sure that when we are cross-multiplying, we will show each step. Do not forget to divide each side of the equation by the coefficients. Let's look at number 1 first. A part of the city building project, architects have constructed a scale model to represent to the City Commission for approval. The scale of the model is 1 inch equals 6 feet. The City Commission would like to install new flagpoles that are 54 feet tall. How tall are the flagpoles in the model? So again, we are going to continue using our proportional one tables. The two labels of the words that we are comparing is inches and feet. What's great about this is they tell you that the scale is 1 inch equals 6 feet. And remember, we said the original is also the scale. So I can put 1 inch and 6 feet. I can then find the other number in the problem, which typically has a label, 54 feet. So I want to make sure that when I put the 54 in my table, I put it also on the row with the feet. We will then cross-multiply and divide the equation to find how tall the flagpole will be in the model. You will cross-multiply. 6 times x equals 1 times 54. And I'm going to solve each step of the equation. This is 6 times x, 1 times 4 is 54. And I can divide both sides of the equation by 6. When I do this, I know that x equals 9. I know that x equals 9 because the fraction 54 over 6 is also a division problem of 54 divided by 6 equals 9. Therefore, our flagpole is 9 inches tall in the model. Let's try number 2 as well. An automobile is 12 feet long. A scale drawing uses a scale in which 1 inch represents 3 feet. What is the length of the automobile on the scale drawing in inches? So for example, when I said they will give you the scale, it says the scale of 1 inch represents 3 feet. So I'm going to set up the 1 table. I am comparing inches to feet. Put my label. My scale is the original ratio given, 1 inch and 3 feet. And then they also tell me that it's 12 feet long. It also has a label, so I know that it will go with these feet. And I am solving for the unknown height of the scale drawing. I can cross multiply. I get 3 times x equals 12 times 1. And you want to make sure that you're showing all your steps. So the first thing I'm going to do is multiply 12 times 1, which is 12. I will then divide both sides of the equation by 3. And I know that x equals 4 inches because this fraction is equivalent to 12 divided by 3, which equals 4. Can you try number 3 by yourself? Did you get 18¼ inches? If not, let's take a look and see which steps you may have missed. Let's look at number 4. A parking lot has 400 meters wide. A scale drawing uses a scale in which 1 centimeter equals 25 meters. How wide is the parking lot on the scale drawing in centimeters? You know what? I think you should try this one by yourself. Did you get 16 centimeters? You definitely want to make sure that you are following all the steps. Take a look and make sure that you have done them. Let's take a look at number 5 together. A flagpole is 25 feet tall. A scale drawing uses a scale in which 3 inches represent 2 foot. How tall is the flagpole on a scale drawing in inches? So we're still going to set up the same 1 table. It says the scale is 3 inches, 2 foot. I'm still comparing inches to feet. My original is the scale given, 3 inches, 2 feet. And it tells me that the flagpole is 25 feet tall. Feet are going to stay with feet. And we want to know how tall the scale drawing is. And you're going to solve this one just like we've done the others. Cross multiply. 2 times x equals 3 times 25. Solve this step by step. 2 times x equals 3 times 25 is 75. We know we need to divide both sides of the equation by the coefficient. And I'm going to come over here and divide 75 by 2. I like to leave my answers as fractions because I feel that it is less steps. But if you prefer to convert yours to decimals, that would be okay too. We now know that the scale drawing of the flagpole is 37.5 inches which is also 37.5 inches. Let's see if you can do 6 and 7 by yourself. Number 6 and number 7 were both a little bit different because this time we were finding an unknown maybe at the bottom of the proportion that we set up on both 6 and 7. I do want to point out that on number 6 you do have to divide by a decimal, and don't forget we don't actually divide by decimals. You do have to make sure you move the decimal on the divisor so that it becomes a whole number, and what you do on the outside, you must do on the inside. I would also like to show you another little trick that if you know that there is a 1 in front of a variable, that 1 is actually considered invisible math. It does not always have to be seen. We know this because 1 times any number is itself. Number 8 is really not any different. We are continuing to use the same proportional 1 table and cross, multiply, and divide to solve. Number 8, a die-cast model of a car was prepared using a scale. 1 inch is half a meter. I can put inches and meters, since those are the two elements we are comparing. It does say that 1 inch is half a meter. If the model measures 6 inches, so we want to make sure that we keep the 6 inches with the inches. We are looking for the actual length in meters. We will cross multiply. 1 times x equals 6 times a half. If I multiply 6 times 0.5, I know that 1x will equal 3. I can multiply these. 6 times 0.5. 6 times 5 is 30. And since I have one number behind my decimal in the problem, I must have one number behind the decimal in my solution. Therefore, the actual length of the car is 3 meters. Don't forget, I did not have to divide by 1 because that creates invisible math. Let's try number 9 together as well. The distance between two cities, A and B, is 180 miles. What is the distance between the cities on a map if 1 mile is represented by 0.04 inches on the map? Number 9 does not tell us they are using a scale. But since I know that 1 mile is 4/100 of an inch, I know that that is my scale. Set up my 1 table, comparing inches and miles. I can put 0.4 and 1 mile. And it also tells me that it's 180 miles. We are looking for inches. Please know that I could have written miles over inches, but for some reason I just wrote inches over miles, I guess out of habit. Cross multiply. 1 times x, look, we have an invisible 1 again, equals 180 times 0.04. I will do my multiplication over here on the side. And since I have 2 numbers behind my decimal in my problem, I need 2 numbers behind my decimal in my solution. Therefore, I know that the distance on a map between city A and city B is 7.2 inches. The cool thing about number 10 is I don't actually have to rewrite the proportion if I choose not to. I can easily see that I have centimeters on the left and miles on the right. If I wanted to, I can just plug 5 centimeters over here on the left, and I know I'm solving for miles. I can cross multiply and divide. I have 1 times x, look at that invisible math, equals 5 times 5 is 25. Therefore, the actual distance is 25 miles. See if you can try 11 and 12 on your own. Did you get 165 miles for number 11 and 190 miles for number 12? If not, let's take a look and see what we might have missed. Remember, when setting up and solving any of these proportions, you must cross multiply and divide by the coefficient and able to get the correct answer. If you have any questions, please ask.